All right, so let's dive into something pretty remarkable.
Okay.
We're talking about a mission that has been going on for almost a half a century, pushing the boundaries of human exploration, further than we ever thought possible.
The Voyager probes.
Yeah,
A testament to human ingenuity and our relentless thirst for knowledge.
exactly. Launched in 1977, originally intended for a 4-year mission
Right.
to Jupiter and Saturn.
Yes,
Just kept going.
They did it.
Now, over 15 billion miles away, Voyager 2 is venturing through interstellar space, beaming back data that's reshaping our understanding of the cosmos. It makes you realize that these probes, built with 1970s technology,
I know.
have outlived many of the people who designed and built them.
It's true. It's a powerful reminder of the enduring legacy of scientific exploration. And speaking of legacy today, we're focusing on one of Voyager 2's key instruments, the Plasma Science Experiment, or PLS, which has recently been powered down.
Yeah, it's a bittersweet moment. So for this deep dive, we'll uncover what led to this decision and explore some of the incredible discoveries this instrument made during its almost 5-decade run. To kick things off, can you give us a quick refresher on plasma and why it's so crucial to study, especially in the context of space exploration?
Sure. Plasma is often called the fourth state of matter, and it's actually the most common state in the universe. Think of it as a gas that's been superheated to the point where the atoms have been stripped of some of their electrons.
Okay.
This creates a mix of charged particles that interact with magnetic fields in fascinating ways. By studying plasma, we gain insights into how stars function, how planets interact with the sun, and what makes up the interstellar medium, the vast expanse between stars.
It's amazing to think that something we might consider exotic here on Earth is actually the most prevalent form of matter in the universe. And Voyager 2's Plasma Science Experiment has been instrumental in unraveling some of plasma's mysteries, hasn't it?
Absolutely. The PLS, developed and built right here at MIT, used 4 Faraday cup detectors to measure the properties of plasma encountered by Voyager 2. These detectors measured the currents of ions and electrons within the plasma, allowing scientists to determine things like its velocity, density, and temperature.
So while it sounds incredibly complex at its core, it's about understanding the movement and energy of these charged particles, right?
Exactly.
Yeah.
And it was through this seemingly simple principle that the PLS helped Voyager 2 make some of its most groundbreaking discoveries. It's really quite a testament to the engineers at MIT and JPL who designed and built this instrument to last.
Speaking of those discoveries, I remember reading about some of them in an article from MIT. It mentioned Voyager 2's flyby of Jupiter and the discovery of the Io Taurus. Can you tell us more about that?
Sure. The Io Taurus is this incredible donut-shaped ring of plasma that surrounds Jupiter formed by volcanic eruptions on its moon, Io. It was a remarkable find because it showed us just how active and dynamic some moons can be. Before Voyager 2, we had no idea a moon could be so volcanically active.
That's just wild. A moon spewing out enough material to create a ring of plasma around a giant planet. It really makes you appreciate the sheer scale and power of the universe.
And that was just the beginning. As Voyager 2 continued its journey, the PLS helped reveal that Saturn's magnetosphere, which is the region around the planet dominated by its magnetic field, was surprisingly full of water and oxygen.
Hold on, water and oxygen around Saturn. Where did that come from?
It turns out those elements were being knocked off Saturn's icy moons by processes like micrometeoroid bombardment and charged particle interactions. This discovery raised fascinating questions about the potential for life in those icy moons and the possibility of finding similar environments elsewhere in the solar system.
So Voyager 2 is already changing our understanding of planetary science right from the start.
Yeah.
And it just kept going, didn't it?
It did. The mission continued to Uranus and Neptune, where the PLS provided crucial data about their strangely tilted magnetic fields, further expanding our understanding of how diverse planetary systems can be. I mean, who would have thought that the magnetic poles of a planet could be almost perpendicular to its rotational axis?
Space is truly full of surprises. It seems like every new discovery Voyager 2 made challenged our preconceived notions about how planets and solar systems work. And as Voyager 2 continued outward, it encountered another remarkable phenomenon, right?
Yes. Beyond Neptune, the PLS detected the termination shock.
Now that sounds pretty dramatic. What exactly is the termination shock?
Imagine the solar wind, the constant stream of charged particles flowing out from the sun as this powerful force pushing outward into interstellar space. Eventually, it encounters the material between stars, what we call the interstellar medium. The termination shock is the boundary where the solar wind abruptly slows down as it pushes against this interstellar medium. It's essentially the edge of the sun's direct influence.
That's such a powerful image. The sun's influence finally meeting its match billions of miles away. And Voyager 2 flew through this boundary.
It did. Both Voyager 1 and 2 crossed the termination shock, and the PLS data was crucial in confirming that. It was a major milestone marking humanity's first foray into interstellar space.
Okay, so Voyager 2 is out there exploring the space between stars, sending back data that's rewriting our textbooks on the universe. But earlier you mentioned that the plasma science experiment had been turned off. That seems like a tough decision to make, especially given its incredible track record. What led to that?
It all comes down to power. Voyager 2 is running on a plutonium power source that's been slowly decaying over the decades. To keep the spacecraft operating as long as possible, the mission team has to carefully manage its remaining power resources.
So even though the PLS was still working, it was using up too much energy.
Unfortunately, yes. The PLS was one of the most power-hungry instruments on board.
That makes sense. It's a shame to see such a groundbreaking instrument power down, but I understand the necessity.
It's a reminder that even the most ambitious space missions have limitations. But the legacy of the PLS and the data it collected will continue to shape our understanding of the universe for generations to come.
Absolutely. But with the PLS turned off, what's next for Voyager 2? Is it just going to drift silently through interstellar space?
Not at all. Voyager 2 is still collecting data on galactic cosmic rays, magnetic fields, and plasma waves with its other instruments, and scientists are hopeful that it will continue to operate, at least in some capacity, until the mid-2030s.
The mid-2030s, that would mean this mission has lasted for over 60 years. But what happens after that? What's the long game for Voyager 2?
Well, that's where things get really interesting. In about 30,000 years, Voyager 2 will reach the distance of the nearest stars.
30,000 years. It's hard to even grasp a timescale like that.
I know.
It really puts our human lifespan into perspective, doesn't it?
It does. And it makes you wonder what the Earth will be like when Voyager 2 makes its closest approach to another star system. What will humanity be like if we're even still around?
It's both humbling and awe-inspiring to think about. And speaking of things that might outlast humanity, didn't Voyager 2 also carry those famous golden records? Those messages from Earth intended for any extraterrestrial civilizations that might encounter them.
That's right. Each Voyager probe carries a golden record, a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. There's music greetings in 55 languages, sounds from nature, and even scientific information encoded in the grooves.
It's like a time capsule, a snapshot of humanity from the late 20th century hurtling through interstellar space.
Exactly. And these golden records might survive for billions of years, potentially outlasting even the Earth itself.
Yeah.
Sobering thought, isn't it? That these records, a testament to our existence, might be the only trace of us left in the universe long after we're gone.
It really makes you think about our place in the grand scheme of things, but it's not just the golden record that carries a message, is it? You mentioned earlier that there was a fascinating detail about one of the spare parts for the PLS.
Oh, that's right. One of the engineers who worked on the PLS at MIT, a man named Robert Butler, inscribed the names of all the engineers and scientists who contributed to the Voyager project on a spare collector plate for the instrument.
That's a wonderful tribute, a permanent record of the people who made this groundbreaking mission possible.
And it gets even more intriguing. Butler, being from New Hampshire, decided to include the state motto at the top of that list of names, "Live free or die."
Live free or die, etched on a piece of Voyager technology, potentially outlasting even the Earth itself. That's incredibly poetic and perhaps a little ironic given the circumstances.
It is. It's a bold statement, a declaration of independence and self-reliance carried on a spacecraft that is, in many ways, a symbol of humanity's collective achievement.
You know, thinking about that inscription and the gold record, it makes me wonder if we were to launch a similar mission today, what message would we send? What would we choose to represent humanity in the 21st century?
That's a fascinating question. What stories would we tell? What music would we choose? What images would we share to encapsulate the essence of our civilization? It's a challenge, but also a tremendous opportunity to reflect on who we are and what we want to project to the cosmos.
Perhaps we should start a global conversation about this, an open call for ideas for a new message to the universe, a message that reflects our current understanding of the world, our hopes, our fears, and our aspirations.
I love that idea. It would be a fantastic way to engage people from all walks of life in a dialogue about our shared humanity and our place in the universe. It could be a truly inspiring project building on the legacy of Voyager and its message to the stars.
It would be a reminder that even though our individual lives are finite, our ideas, our creations, and our collective spirit can have a lasting impact.
And who knows, maybe someday, billions of years from now, Some other civilization might encounter our message Voyager or even that spare part with its inscription.
And perhaps they'll get a glimpse of who we were, what we valued, and the incredible things we were able to achieve.
It's a humbling thought, and one that fills me with a sense of wonder and hope.
Me too. Despite having to say goodbye to the plasma science experiment, it's clear that Voyager's journey and its capacity to inspire is far from over.
Indeed, as Voyager 2 sails silently through interstellar space, it carries with it not only the dreams of those who built it, but also a piece of our shared humanity, a message in a bottle cast out into the cosmic sea.
This has been such an incredible deep dive. It's amazing to think that we launched these probes nearly 50 years ago, and they're still out there pushing the boundaries of our knowledge and challenging us to think bigger, to think beyond ourselves.
Voyager's mission is a testament to human ingenuity, our thirst for knowledge, and our enduring spirit of exploration. It's a reminder that we are capable of extraordinary things when we set our minds to it.
And what about that inscription on the spare part? It raises an interesting thought. While live free or die might be a bit bold, what message would you want to send into the cosmic abyss? What message would best represent humanity to the universe?
That's a question that could spark a lot of discussion.
It really could. And maybe
Yeah.
that's the point. It's not necessarily about finding the perfect message,
Right.
but about the conversation itself. The act of considering what represents us, what we value, and what we want to share with the universe, that's where the real meaning lies.
I completely agree. Voyager's journey has always been about more than just data and discoveries. It's about pushing the boundaries of our understanding, inspiring future generations, and encouraging us to think about our place in the cosmos.
And to remember that we are part of something much larger than ourselves.
Precisely. And even though the plasma science experiment has been powered down, Voyager 2 continues to be a symbol of that connection, a testament to our enduring curiosity and our desire to explore the unknown.
It's incredible to think about this little spacecraft launched decades ago, still out there carrying a piece of humanity with it. It's almost like a message in a bottle drifting through the vast ocean of space.
And who knows, maybe someday, far in the future, someone or something will find it. Maybe they'll decipher the golden record. Maybe they'll even stumble upon that spare part with its inscription. It's a humbling thought, isn't it? That a piece of our history, our ingenuity, might outlast us all.
It really is. It makes you appreciate the power of long-term thinking, the idea that our actions today can have repercussions far into the future.
And it highlights the importance of making choices that reflect our values. Choices that will leave a positive legacy for generations to come.
Well said. I think we've covered a lot of ground today, from the science of plasma to the philosophical implications of Voyager's journey. What are some key takeaways you hope our listeners will walk away with?
Well, I hope they'll remember the incredible ingenuity and dedication of the people who made Voyager possible, the groundbreaking discoveries it made, and the enduring power of scientific exploration. And perhaps most importantly, the reminder that we are part of something much grander than ourselves, connected to the cosmos in ways we may never fully comprehend.
Beautifully put. It's been an absolute pleasure diving into this topic with you. And to our listener, we hope this deep dive has sparked your curiosity and inspired you to learn more about the Voyager mission, the wonders of plasma science, and the vast universe we inhabit. Keep exploring, keep asking questions, and never stop looking up at the stars.